Good afternoon, sir. This is Ravi Shankar. I'm here to teach you networks, and I'm starting it from very beginning. Let's talk about the electric charge. The definition of electric charge is an physical property of matter that can causes it to experience a force when it kept in electric or magnetic field. Unit of electric charge is coulombs. Okay. Here I'm talking about the matter. Okay, this matter consists of electron and proton. If there is more number of electron uh, in comparison to proton, then our matter consists of negative charge, and if our proton is more number than electron, then our matter consists of positive charge. Okay, then charge of electron. What is the charge of electron? It should be equals to minus 1.6 into 10 to the power minus 19 coulomb. Okay. Charge of proton. One proton having charge equals to 1.6 into 10 to the power minus 19 coulomb. Okay. Let's talk about the law of conservation of charge. Okay. Law of conservation of charge uh, states us that charge cannot be created or nor destroyed. It can be only transferred. So we can write it summation q equals to 0. Summation q, we can write it q1 plus q2 plus up to qn. It should be equals to 0. Okay. Flow of electric charge. Let's talk about flow of electric charge. Okay. If we pass electric current through a conductor, let's draw it. Here is a conductor, and when we connect it from a battery source, okay, when we connect this conductor to a battery source, a current will starts flowing from its positive terminal to negative terminal. Meanwhile, in conductor, flow of electron and proton takes place in opposite direction. Let the direction of current is this one, then direction of proton will be this one, and the direction of current would be the opposite to the direction of electron. So current direction is from this side to this side. It starts from positive polarity of battery and goes to the negative polarity of the battery. Here is positive polarity and here is negative polarity. Okay, let's do the second slide. Electric current. What is electric current? The definition of electric current is the rate of change of charge is known as current. Unit of electric current is ampere. Mathematically, the relation between current, charge and time is given as I equals to dq by dt. Okay. Here we can see it. Rate of change of charge. Rate of change of charge is with respect to time is equal to current. Okay. Let it integrate both sides. Then we can find q equals to integration from t0 to t1 I dt. Okay, this expression is very useful for calculation of numerical problem, which we will discuss later. Okay, now electric current has two types. It may be our dc current, it may be our ac current. Okay, dc current is that type of current which has constant all time throughout all time. Okay, here suppose I have a current magnitude 5 ampere. Then if we talk about this point, let it t1 and it t2, then here we have 5 ampere current and at t time, at t2 time we have also 5 ampere current. So our DC current is constant throughout the time. Okay, AC current. AC current is has varying nature with respect to time. Let's talk about uh, sinusoidal current. We can draw this sinusoidal current. We have, let it peak magnitude is 5 ampere. We can write it as I equals to Im sin omega t. Then we have Im equals to 5 sin omega t. This one is omega t. Okay, if we talk about at this point pi by 2, and this point is pi, this point is 3 pi by 2, and this point is 2 pi. We can see it with the diagram that at time t equals to pi by 2 we have magnitude 5 ampere. Okay, and at time t equals to pi we have magnitude 0. So we can conclude from this one, we can conclude from this one that AC current has varying nature with respect to time. Okay, let do one problem. How much charge represented by 5 electron? Okay, we have to solve this problem, that how much charge represented by 5 electron. Acha, as we have mentioned earlier, 1 electron has equals to minus 1.6 into 10 to the power 10 to the power minus 19 coulomb charge. So we have to find 5 electrons charge. So here we can write it as 5e. So we can do a little bit calculation. So we can see it minus 8 into 10 to the power minus 19 coulomb. That 5 electron charge is 5 electrons is represented by 8 into 10 to the power minus coulomb. Okay, let do second problem. We have second problem. Total charge entering at a terminal is given by q equals to 5t sine 4 pi t milliampere. Find current at t equals to 0.5 second. Okay, as we have seen current current we have seen expression between current and charge and time, that it is I equals to dq by dt. Here we have q, and we have to find the current. Okay, let put it current charge value here. So we can see it 5t sine 4 pi t. So we have to differentiate it with respect to time. So let's do it. Okay, let's 5 common, and here t sine 4 pi t, it with respect to t, we if you differentiate it, it will be 4 pi t, and differentiation of 4 pi t would be 4 pi. Now plus we can write differentiate t with respect to t, we have 1, and cos for sorry uh, we have to write here sine 4 pi t. Okay, let put at time t equals to 0.5. We are doing it for t equals to 0.5. So 5, this will be equals to this 4 pi t into cos 4 pi t plus sine 4 pi t. So if we put t equals to 0.5, then it would be 5, it will be 2 pi cos 2 pi plus sine 2 pi. Okay, so if we draw cost function with respect to time, we see it this one. Okay, here we have equals to this one pi by 2, this one pi, and this one 2 pi. So we can see it from here that cos pi would have magnitude value 1. Okay, so we can put here 1, and let's see value of sinusoidal function. Then it would be here pi and here 2 pi. So sine 2 pi value is 0, so we can put it 0 here. So we have value 5 into 2 pi multiplied by 1 plus 0, so we have equals to 10 pi. It is our answer. Okay, okay, let's go to the next slide. Our next problem is determine the total charge at a terminal between t equals to 1 second to t equals to 2 second if current passing the terminal is I equals to 3t square minus t. Okay, as we seen the uh, expression of current, that I equals to dq by dt. Here we have I, so here we have I, so we have to integrate this expression both side, so we can get q equals to integration from t1 to t2 I dt. Okay, we our range is 1 second to 2 second, and I equals to 3t square minus t, and difference integration. Okay, if we integrate this one, 3t cube by 3 minus, sorry, it would be minus t square by 2 from 1 to 2. This 3 and 3 cancel out, put upper limit and lower limit, so we have 2 cube minus 1 cube minus of 1 by 2 and 2 square minus 1 square, so it would be 7 minus 1 by 2 and 3, it would be 1.5 and it would be 5.5 Coulomb. Okay, this is our answer. Okay, let's start with let's start with voltage. Here voltage, definition of voltage: voltage or potential difference is the energy required to move a unit charge through an element. Unit is voltage. Okay, mathematically it can be written as V equals to dW upon dq. Okay, mathematically it can be written as V equals to dW by dq. Okay, and unit is volt, and if we write unit of work is joule, and unit of uh, charge is coulomb, so its unit would be joule per coulomb also. Okay, let's go to the next slide. Here, power definition of power is rate of delivering or absorbing energy with respect to time is known as power. Its unit is watt. Rate rate of delivering or absorbing in a particular in a network we have um, delivering source and absorbing element. Okay, we will talk it here. Absorbing power, let's we have four more circuit here, and trying to think about visualize the absorbing power and delivering power from here. This is the concept is current entering through positive terminal of an element uh, is we have power positive. Okay, current entering through positive terminal. Let's see here, current entering through positive terminal. See it here, this is our positive terminal, and this is direction of current entering through positive terminal. We have absorbing power, we have power positive. Okay, how? Let's, we have 5 ampere current entering to the positive terminal of voltage, we have 5 volt, this is 20 watt. Okay, this is positive. So positive means this element is absorbing power. Okay, let's think about this one circuit. Okay, current here, direction of current is this one, and it would be from as like this one, it would be this one. Okay, current, this is our positive terminal and this is the direction of our element current. So current entering here, current is entering to the positive terminal, so we can write it uh, we can write it 4 into 5. So we have here power equals to 20 watt. Okay, this is also our absorbing power. Here in the third circuit we have we can see it from here, this is the current direction of current, and it would be like the this one. Here we can see it from here that our uh, direction of current is entering to the negative terminal, means we have delivering power. Here we can write it as like 4 into multiplied by 5 volt, we have minus 20 watt. This sign shows the delivering power. Okay, our circuit is delivering power. Okay, this one, try to think about this one. We have a negative terminal here and direction of current is entering to the negative terminal, means our power is here also negative 20 watt. So I think you guys are very comfortable to deal with the absorbing energy and delivering energy source. Okay, let's go to the next slide. And note, in any closed circuit absorbing power should be equal to delivering power. Okay, in any closed circuit absorbing power should be equal to the delivering power. Okay, means suppose we have absorbing power P1, P2 in any particular circuit, and we have delivering power, let's suppose P3. So from our concept we have to write it P1 plus P2 equals to P3. Okay, okay, this leads to conservation of energy, must be obeyed. Okay, definition, energy Let's talk about the definition of energy. Energy is the capacity to do work. Unit of energy is joule. um, we can write here E equals to integration of T naught to T1 pt. Okay, we can write it this one also. We can write energy is equals to T naught to T1 V into I dt. Okay, so we can write it capacity to do work means dw upon dt. We can write it uh, also dw upon dq into dq upon dt. So dw, as we have read earlier, dw upon dq equals to uh, voltage and dq upon dt equals to current. So we can write it v into I. Energy equals to v into I. Let's go to the next slide. This is problem number 4. How much energy does 100-watt electric bulb consume in 2 hours? So um, we can energy consumption of energy. We have to find consumption of energy. So energy, we know E equals to P into T. Okay, we have 100-watt bulb. Okay, T equals to, we have 2R. Let's put it here, 2R. It would be 2 watt hour. Okay, and if we write 100-watt 2 and 2 hour, if we change it in second, it would be 16 to 16. After solving this, we can get it 200 and 3600 and 72 and 4 more 0. Okay, so we can write it 720 kilo 720 kilojoule. ठीक है, we can write it 720 kilojoule. We have energy in 2 hours. Okay, thank you.